Hello and welcome to Technical Kranti, and today we are going to see the second question on recursion. Overall, this is a third video on recursion. So let's get started and let's have a look at the thought for the day. All right. So these are the videos that we have released in the recursion series, and this is the question. So question basically states that you are given an array. You need to find the unique subsets of the array, all the unique subsets of the array. For example, if this is the array that is given to you, then just for the sake of clarity, 121 and 112, these are having the same elements, right? So only one of them will come, which is 112, and the answer should be something like this. So here no array is repeated, or in other words, all subsets are unique. How are we going to do this? So let's have a look. We have 1 1 2, right? What we did in the previous question, we say that okay, I can include the first element or I cannot include the first element. Then the decision making comes on the second element. I can include it or not include it. Similarly over here, I can include it or not include it. And then the decision making comes on the last element. Include, not include, include, not include, include, not include, include, and not include. All right. So in this way, we have generated subsets, but there are some repeated subsets. For example, this and this is a repeated subset. So what we do in this approach is we just generate all these subsets, and then whatever is duplicate, we don't add it to the final answer. So let's have a look at the code of it. So yeah, as you can see that I am calling this function, which is basically doing the recursion. This is the index to begin with. This is the subset. This is the complete array. And this is the final answer. This is the length of the array. So what we are doing is, for index is equal to 0, we say either include it or do not include it. How are we including it? In the subset, we add the element, or we move on to the next index without adding the element into the subset. And this way, we finally at the end, we see that if the subset is in the answer, then again do not add it again to the answer, otherwise add it to the answer. And that's how we generate the subsets. So as you can see, I have already printed the output of this program, and we have all the subsets with us. But again, I'm reiterating what we did. We generated the subsets which had some duplicate subsets, and then we added only the unique ones. So we kind of did something more during generation, and as a result, at the time of adding to the answer, we had to do something more to filter them out. How if we can generate only the unique subsets? If we can generate only the unique subsets, we can add them to the answer, and this would be more optimized approach. So for this, we need to understand the root of why this duplicacy happened at the first place. So this duplicacy happened because this was generated. All right. And why this is generated? So we'll see that this one is coming from here, and this is the first one. The first one when considered at the first recursion call, and at the second recursion call when the second element was not added to it. That's how we got this particular element. And how did we reach over here? So at the first recursion call we did not consider the first element, and at the second recursion call we considered this particular element, and as a result in this particular subset, one comes from two different sources. So at first position one comes from this one, and again at the first position one comes, which is this one, right? So what if we can say that first one only comes at the first position and the second one comes at the second position? If we associate the position with these ones, then what will happen is that this and this will form, because this is the first one, this is the second one. Then this will be one subset that will be formed, and then finally this will be formed. So with the combination of these ones, only these three will be formed, as against now where this is coming twice, because this blue one is also forming a similar subset. So what I have done, I'll repeat again, I have associated position with the same numbers. So if there are same numbers, the first one will occupy the first position and the second one will only occupy the second position. It will not occupy the first position. So how are we going to implement it? So we have 1 1 2 with us, and to begin with we start with an empty subset, and we point to the next index to be considered, which is 0. All right. So this serves as the basis of the recursion which will happen next. So at the second, I mean at this level, at the first recursion call, what will happen is we'll consider this one at the first position, okay? And for the subsequent recursion, the index to be considered would be 1. And we will consider this particular element at the first position, and there is no index after it. So there will be no more recursions after this, right? Okay. Now this will result in the second recursion call, right? And for that, what is the index that we are considering? 1. So then there will be this particular subset generated, and this is the next index that needs to be considered, okay? And there will be one. So from 1, when included, like when so there will be a for loop, all right? So there will be a for loop from 0 to 2 at this level. At this level there will be a for loop from 0 to 2, all right? So when the index is 0, the subset formed is 1. We'll not consider this particular. And when index is 2, the subset form is 2. All right. And from here, the loop will start from 1 to 2. Right. 1, because this is what serves as the starting point of the next loop. And as a result, the subset form is 1 1 and 1 2. All right. And there will be no more recursion after this because no index is left. And over here, the next recursion, this will serve as the basis for the next recursion call. So then the loop will run from 2 to 2, and this will be f of 1 1 2, and no more recursion calls. So what is the final answer over here? So this is the answer. This is an answer. this is one subset, this is one subset, this is one subset, and this is one subset. All right. All right. So we start the recursion in the same way, but to begin with, we'll sort the array. Okay. And then, as you can see, to begin with, we start with index 0, and the first loop runs from 0 to n. All right. Now, this particular if condition checks that we do not include the repetitive elements after the first element, right? So, first element needs to be considered anyways. So this check is because if you see here at the second level, we start from this particular index, right? This particular index from 1 to 2. Now, this is similar to this element. So, but we need to consider this when we are starting from here, we need to consider this, right? So that is why this condition is there, that when I is greater than the index that you started with, and then the elements are same, then you don't need to consider that element. Append the element to the subset and do the recursion call. And after the recursion call, it is very important to remove the element, right? Because as you know, recursion, what happens is the left leg is computed first, and as soon as the left leg is over, we go back to the parent, the immediate parent, and the immediate parent does not have the last added element. That's why we have to remove the last element added, and this recursion would generate the output that is explained over here. All right, so let's see if we get the right answer. So yes, the subsets generated are the same. So I hope you understood the problem and the approach that we took in the naive approach and the efficient approach. And yeah, if you did like it, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.